All right, welcome to second semester. So you can see on my screen, I started recording videos for chapter 9 before me and Miss Carp decided to do chapter 11 first since I'm going to be out. And so when you get to the 9.1 video, I think I'm going to say welcome to second semester again. So that'll be fun. All right, so 11.2 systems of linear equations. And you're like, oh my gosh, this is an easy Algebra 1 topic. We're going to solve them using matrices. Matrices are not difficult, it's just new. But we are going relatively slow through this. So pause me and take a minute to copy this down. All right, so an augmented matrix is an alternate way of representing a system of equations. So we're used to seeing x plus 2y equals -4 and 3x minus 4y equals 1. And in an augmented matrix, it's written in this form. So we take the coefficient of x, which is 1, and the coefficient of y, which is 2. The bar represents the equal sign, and then we've got the -4. Next row, we take the coefficient of x, which is 3, and then the coefficient of y, which is -4, the bar, and then the 1. So to solve systems using augmented matrices, we're going to use row operations. So we can interchange two rows. Basically, that's just like writing one equation on top of the other instead of vice versa. We can replace a row by a non-zero multiple of that row. So that's basically taking an equation and multiplying it by a number. We do that in the elimination method. So this is basically the same as multiplying by a constant, multiplying an equation by a constant. And then we can replace a row by the sum of that row and a non-zero multiple of another. So what is this the same as? We multiply a row by something. Remember, a row is just representing an equation. So we multiply a row by a number that's not 0, and then we add it with another row or equation. What is that the same as? Well, I kind of just gave it away. That's the elimination method. Okay. All right. So we're going to start today solving systems by getting them into row echelon form. And row echelon form is an augmented matrix. So you've got the matrix entries with the line down representing the equal sign. The diagonal has 1s all along, and everything below the diagonal is 0. Anything above the diagonal can be whatever the heck it wants. Okay, so we're going to solve a system using matrices. We're going to get this into row echelon form. So I'm going to start by writing this as a matrix. An augmented matrix. So I'm taking the coefficients of x and y, and then the number, the constant after the equal sign, and then the 4 and the 2, and so on. So there's an order that I want to do these things to be so that I don't undo any of my work as I'm working. The first thing that I want to do is get a 1 in that top corner. And that's really easy to do. What I'm going to do is multiply this row by 1/3. So I'm using this rule here that says I can replace a row by a non-zero multiple of that row. So multiplying by a constant. So if I multiply that row by 1/3, so I like to write off to the side. I'm giving myself a new row 1 by multiplying the old row 1 by 1/3. So I'm going to end up with 1, 1, 1. And I didn't do anything to that row. All right. So that's an example of the first row operation. Nope, the second row operation. Multiplying by a constant. Okay. The second thing I want to do in all of these, every time I'm putting something into row echelon form, The second thing I want to do is get a 0 in the entry below the 1. So the way I'm going to do that now, this is where I'm going to use that elimination, that number 3. So I'm going to create a new row 2 by multiplying row 1 by -4. I'm on a little bit of a delay, and adding it to row 2. So if you want to, you can kind of like write it down here so that you, sorry, I'm on a delay, so that you can add them together more easily. So writing row 1 times -4 below row 2 and then combining. So I'm going to combine the blue and the orange. So then I might need to, like, off to the side be like, well, what's 8/3 minus 4? It's -4/3. And I'm going to leave the top row the same this time. So first step is to get a 1 in the top corner. Second step is to get 0 below. So I've done that. And then since this is just a small matrix, this is called a 2x2 matrix in the front here, there's only going to be one more step. And that is going to be, let me pick a different color. Let's do purple. That is going to be to finish off that diagonal of 1. Remember, our goal is for it to look like this. 1's along the diagonal and then 0's under the diagonal. So I'm going to create a new row 2 again by multiplying it by -1/2, the old row 2. So basically when I want to create a 1, I'm going to just multiply the current row by whatever is going to create a 1. When I want to create a 0, I'm going to multiply a different row and combine to make 0. Okay? So if I multiply by -1/2, and you probably don't need to do this, but I'm really tired, so I'm going to do it off to the side. I'm going to multiply the -4/3 times 1/2, and I'm going to get -2/3. And I didn't do anything to row 1. So this is called row echelon form. Okay? Now, why does that help me? Because now I have x plus y equals 1 on top. It's going to catch up. And then I have 0x plus y equals -2/3, right, on this second row here. So then I can plug that in, add 2/3 to both sides. And I've got my answer. So this answer represents the same as always when we're solving systems. If I were to graph the two lines that were given to me up at the top, I would find that they have a point of intersection of 5/3, -2/3. All right, so take a minute and copy that down. Okay, so reduced row echelon form, the only difference, now this is just a bigger matrix than the previous one. The only difference is instead of just having 0's below the diagonal, we have 0's below and above the diagonal. And I'll show you why I actually prefer solving using reduced row echelon form as we solve a problem. Okay, so let's do an example. So first thing, I'm going to write this as an augmented matrix. Just taking all the coefficients, drawing my line to represent the equal sign, and then drawing the, writing the constants. Let me just make sure I did that. I don't want to write anything down wrong. Okay. Now, remember the first goal is to get a 1 in the top left position. I would recommend that we take our row 1, oops, that was bigger than I wanted it to be. We take our row 1 and switch it with our 3. Doesn't matter if you use capitals or lowercase for that one. So that then I'm going to have an easy way to get that 1 in the top left position. And all that really is doing is, like I said before, it's like writing the equations in, a different order. I have this equation on the top and this equation on the bottom, and of course we can do that, okay? Then our second, so I'm not color coding this, am I? The first goal was to get a 1 in the top. Sorry, can't see that. The first goal was to get a 1 in the top. The second goal is to get zeros underneath. So, like I said before, I'm going to rewrite. I'm just writing my row operation indicators on the right just because I feel like it's neater. It was kind of bugging me in the previous example. So when I'm trying to get zeros, I'm going to use the one that I already got. I'm going to create a new row 2. I'm going to create a new row 2 by multiplying the old row, by multiplying row 1 by -3 and adding it to the old row 2. That's going to give me a 0 in my first position in row 2. So I'm going to go, what am I multiplying by? I'm going to have those values, and when I combine them, I get that. And then I'm going to create a new row 3 by multiplying my row 1 by -2 and adding it to the old row 3. So I'm always using that one that I created in row 1. So I'm going to multiply the top row by -2, multiplying the top row by -2 and combining those. Now I have my 0, 0. Oh, and look at this! Exclamation point. I got my goal is already done. I happen to have a 1 in that middle position along the diagonal, so that actually saved me some work. So now I'm going to, I'm trying to find a color that I haven't used yet. Okay, so now I'm going to create a 0 below and above that 1. So I'm totally going to run out of time on this video. So the thing about this recording method is I only have 15 minutes. I'm going to create a new row 1. I'm going to use the one that I created in row 2. And all I need to do is add those two together to get a 0 in the spot that I want it. So I'm combining row 1 and row 2. I'm going to create a new row 3. I want to create a 0, so I need to multiply row 2 by 5 and add it with my old row 3. So I'm going to write row 2 times 5. I mean -5, sorry. I'm going to combine those. Whoa. My screen just jumped. I'm going to combine those. Oops, that's a positive. And I'm in the home stretch. I'm going to next, gosh, I'm running out of colors. I'm going to use a dark green instead. I'm working along the diagonal, so my next goal is going to be to get a 1 there. And that's super easy to do. All I need to do is multiply row 3. It's going to be 1 over 57 times the old row 3. And I'm out of time.